Good day, students. Today we're going to look at a solution to another adding and subtracting rational expressions. Practice 5 in book 2 of your ma1026 booklets. So this particular one is number 21 on page 29. Okay, number 21 on page 29. Now this one, okay, adding and subtracting, in this case subtracting two rational expressions, okay, involves factoring, of course, and simplifying before we add or subtract. Now you'll notice this particular example versus other ones. Look at the numerators. It looks like both numerators have a GCF, and if that's the case, I encourage you to check it out and see if that helps simplifying the numerators. In the previous examples we only factored the denominators, but here if you look at the top one, we have a GCF of 5, so we factor that out. We're left with x plus 5. And again, anytime you want to check a GCF, multiply it back out and see if what you get. 5 times x is 5x, 5 times 5 is 25, and make sure you did it correctly. Now the bottom part here is a trinomial, so I'm going to take that trinomial over here, 2x squared plus 13x plus 15, and I'm going to factor that using a method called product sum. Okay, so in this case the product here is the leading coefficient times the last number, so in this case 2 times 15. That's the product I'm looking for, which is 30, and the sum I'm looking for is the middle term, which is just 13. Okay, the sum is positive, so both positive numbers. So what two numbers multiply to give me 30, but when I add them I get 13. Now if you tried 15 and 2, 15 times 2 is indeed 30, but 15 plus 2 of course is 17, so that doesn't work. Alright, so we have to try two other numbers, and I think most of you probably see them by now. Oops, let me get rid of that. Alright, so let's look at 10 and 3. It looks like 10 and 3 are our numbers. 3 times 10 is 30. 10 plus 3 is 13. Now what do you do with those two numbers once you've found them? Once you find those two numbers, this is what the middle term becomes. So you decompose or break down the middle term to become, right, 10x plus 3x. So those two numbers, that's what they're used for, to break down the middle term. So what do you do with the other two numbers? Of course, in this method you just rewrite 2x squared, and you carry down the 15. So now you have 4 terms. So basically you made the middle term 2 more terms. So you've gone from 3 terms to 4 terms. And it's sort of like the FOIL method backwards, right? We talked about this before. Now you factor by grouping. GCF in the first group is, if I take 2x out, I'm left with x plus 5. And GCF in the second group, of course, is 3, and I'm also left with x plus 5. Now if you do this method correctly, of course, you're going to have now a common binomial in each group, and which we do, x plus 5, and the remaining binomial is your other factor. Okay, so let's put back in our question. So don't try to do all those steps inside this problem. Do them separately. Go to a separate page or a piece of scrap paper or a side of your book, something. Now just let me, don't want to mix up that, so I'll just put a little dotted line there. Now the next one, I'm doing the top here on this one right here. Now have a look at this one. I see 10 is a factor, a GCF, left with x minus 2. And in the bottom one there, let's see what you see, x squared minus 4. You notice that? Yeah, that's a difference of 2 squares. So it's x minus 2. Well, let me get rid of that circle first. That's x minus 2, x plus 2. Now, everything is factored. Now, within the fraction itself, within the single fraction, like I cannot cross cancel across a minus sign, right? Like I wouldn't be able to cancel anything right on the other side over here with something here. I cannot do that because of this minus sign in the middle, right? You can only cross cancel when it's multiplication in the middle. But I can within the fraction itself. So I have two fractions here. Can we simplify just within that fraction? Because, and we can see the x plus 5 is common to both top and bottom. Okay, but you can only simplify here within that fraction. So that makes life a lot easier for us. Look at that. And if you look at the second one, they're also canceling within the fraction. I can cancel here as well, leaving me with 10 over x plus 2. Okay? So now you can see it's a much simpler fraction. Okay? So that's why we factor both top and bottom, to see if we can make it simpler. Now our LCD is just one of each factor. So it's going to be 2x plus 3 times x plus 2. Right? So that means I have to multiply this fraction by 2x plus 3 to make my denominators the same. And of course that means I multiply this one by x plus 2 to make those equal. Now be careful again with that minus sign in the middle. I encourage you to write this extra step. Put whatever number is in front, the monomial, open your brackets, put your binomial in brackets, minus your single number or monomial times your binomial in brackets. And again, you don't have, at this stage you don't need to write it twice, but you can. Or you can write one single denominator. Now you cannot cancel again at this step. You cannot cancel here, okay? Because of this minus sign here. This minus sign means I can't cross cancel or cancel anything in the numerator with anything in the denominator yet. Always simplify at this stage, okay? So we have to multiply. We're going to use the distributive property here. We're going to use the distributive property here as well, giving me 5x plus 10 minus 20x minus 30. See how the minus now goes with it? So watch, careful with the sign. It's plus here times the minus here, which is going to end up with, of course, minus 30 below. All over 2x plus 3 and x plus 2. Now where does that bring us? So the next step now, follow me here, we can add those like terms. Let's see, I get 5x minus 20x, that's negative 15x, plus 10 minus 30 gives me minus 20. Alright, and on the bottom I got 2x plus 3 and x plus 2. So what else do we see? Alright, what else can we do? Well, I see a GCF of negative 5 on top, looks like, leaving me with 3x plus 4. Let me double check that. Negative 15x, yeah, that's correct. All over 2x plus 3. Now factoring doesn't help us because we still can't cancel anything, right? So there's your final answer for number 21 on page 29. There's your final answer right there. Adding and subtracting rational expressions.